Homework 2.3, Linear Functions and Slopes, Video 2. Homework due Friday, May 22nd, 2020 at 11:59 p.m. I'll go ahead and mention that at the conclusion of this video, you should try questions 1 through 5 on the homework for 2.3 because they'll be similar to the problems that you're seeing now. I've got 4 examples of pairs of points, and we're going to calculate the slope of the line that goes through each one of them. Now, it's not necessary to sketch a graph of these lines, but after we calculate each slope, we're going to sketch a quick graph of each line, which is easy. Plot the points and connect them, and see what information we can gain about a line based on its slope. So let's start with number 1, where we're finding the slope of a line that passes through the point -1, 2 and 3, 8. Our slope formula is still over here. When you set up the formula for the slope, it's a good idea to go ahead and draw the fraction bar and both subtraction signs. That's what I call the structure of the formula. And then you can just substitute the values as necessary. Now before you go sticking in values, at some level, you need to identify who is whom. For example, this is the first x. I'm going to write x1 above it. You don't need to, but you need to at least think that's x1. And the minute you call this x1, that means that this is y1, x2, and y2. It really didn't matter which one I called x1, but the minute I decided it, everything else was decided for me. And then carefully insert all the values, including their negative signs. For example, the first part on the top is the second y, which is 8. The other side of that subtraction sign is the first y, which is 2. Downstairs, on the left side of the subtraction sign is, whoa. Sorry. So you see the error in the formula? It's x2 minus x1, not x2 minus y1. I don't know if I was just careless or if I didn't complete the second part of the x and just cut it off too short, but the denominator of the slope formula is x2 minus x1. So back to the problem. Second x minus first x, so 3 minus -1, 3 minus -1. A common mistake in calculating slopes is extra negative signs, so just stay focused. In the denominator, we have the double negative, or minus a negative, so that would become plus a positive. And now we can just work out each one. In the numerator, 8 minus 2 is 6. In the denominator, 3 plus 1 is 4. And you are expected to reduce, so that would reduce to 3/2. So the slope of that line is positive 3/2. I invite you to pause the video and try to calculate the remaining slopes. Most of them behave. Notice I said most of them. There is one of them that misbehaves a little bit. All right, let's take a look at part B, where we're finding the slope of the line containing these 2 points. It's really just the same song and dance, you just have to be careful. Again, at some level you need to identify first x, first y, second x, and second y. So which of these is the first x, the -3 or the 7? We would all probably say -3, but I'm going to use 7. Why? Well, think about it. The order in which these points is written is completely arbitrary. I could have written this point first and this one second, and then coaxed you into calling this the first x. But it really won't matter. We'll get the same answer either way. I'll explain why at the end of this one. If we happen to call this the first x, then -6 is the first y, -3 is the second x, -1 is the second y. Again, I can do that because if I wrote the second order pair first and this first one second, I'm still going to draw the same line. It should give me the same slope. So let's see what happens if we set it up this way. Second y is -1 minus the first y is -6. There's a double negative. Second x is -3 minus the first y is 7. Let's work it out. On the top we get -1 minus -6, so the double negative becomes a plus positive. -1 and +6 is +5. In the denominator, -3 minus 7 is -10. And this fraction will reduce to -1/2. Had we ran with this being the first point and this being the second point, then the top would have been -6 minus -1 and given us -5, but the bottom would have been 7 minus -3 and given us +10. In other words, by switching the order of the points, we would get the opposite results on both sides of the fraction, but we would have gotten the same net result. Instead of getting 5 over -10, we would have gotten -5 over +10, and it still would have reduced to -1/2. So it really doesn't matter what you call first or second. All right, let's try the next one. Did you notice anything about the two ordered pairs in part C? Here's the structure of the formula. Let's just jump right to it. We'll put the second y here. Who's the second y? Actually, both y's are the same. They're both 11. But if we do second minus first, who's the second x? We'll say the 9 is the second x. First x is 5. Then we get 0 on top of 4. Can we do that? Can we do 0 divided by 4? If you have $0 and share it with 4 friends, how much does everybody get? 0. It's okay if 0 is on the top of a fraction, as long as you don't have 0 on the bottom. So this line has a slope of 0, and I wonder what that means if we're measuring how steep a line is. For the last one, let's go ahead and set up our structure, and let's insert our values. The second y, we'll call it 7 because it's literally the second one listed, minus the first y. The first y is 4. Nothing to worry about there. And in the denominator is the second x minus the first x, but the x is MASH. So -2 minus -2. Let's see what happens. The top is easy. 7 minus 4 is 3. But on the bottom, we get a double negative, so it becomes a plus plus. -2 and +2 is 0. Now we have a problem. 0 on the bottom of a fraction is undefined. So if you get a 0 on the bottom and not on the top, that means that the slope is undefined. I may pause and insert an extra video because I've got a lot more I want to say about all 4 of these, but I fear that this has already surpassed the 10-minute mark. Oh no, we're only at 7.5 minutes. I'm good. Don't need to insert an extra video. All right, so let's recap what happened on these 4 problems. All of them started the same, using the slope formula. I decided to be goofy here and call this the first point and this the second point, but it doesn't really matter because the order of the points is arbitrary. We'll get the same slope either way. So one slope was 3/2, one slope was -1/2, one slope was 0, and we got a slope that was undefined. What I would like to do with all of these is kind of get an idea of what those things mean. What does it mean when the slope is positive? What does it mean when a slope is negative? What does it mean when a slope is 0? And what does it mean when a slope is undefined? And we can get a visual on each one of them by quickly sketching these lines. And these don't have to be super accurate. For example, for A, -1, 2 is about there. 3/8 is over 3 and it's a lot higher than 2, so it's up here somewhere. So if we connect those, we get a line that's increasing from left to right. And the slope is positive. What do you think will happen when the slope is negative? Let's see. -3, -1 is back 3 and down 1. 7, 6 is over 7, but down further. Oh, look at that. The slope was negative and the line was decreasing. So right away we can conjecture a couple of things, and I'll tell you right now they would be true. If a line slope is positive, then the line is increasing. If the line slope is negative, then the line is decreasing. In fact, I'm going to categorize these things. If the slope is, then the line is, and I'm going to make a table. If the slope is positive, then the line is increasing, and vice versa. If a line is increasing, then its slope is positive. If the slope is negative, then the line is decreasing. But we have 2 other scenarios. If the slope is 0, and if the slope is undefined. Well, what do you think will happen there? Well, it can't be increasing or decreasing, so how can a line be neither increasing nor decreasing? Oh, wait, increasing, decreasing constant, also known as horizontal. Which of these lines is horizontal? Let's graph them and see. Part C, 5, 11 is over 5 and up really high. 9, 11 is over 9 and up the same amount. So we get a horizontal line. And when the slope is 0, the line is horizontal, which kind of makes sense if you remember that slope is measuring steepness. How steep is a line that has no steepness? 0. But what about this last one? What does it mean visually for a slope to be undefined? Well, let's see. Negative 2, 4 is back 2 and up 4. Negative 2, 7 is back 2 but up higher. So those points are right above each other, and when we connect them, we get a vertical line. Oh, okay. So to summarize, if a slope is positive, then the line is increasing. If a slope is negative, then the line is decreasing. If a slope is 0, then the line is horizontal. But if the slope is undefined, then the line is vertical. And I want to point out that having a slope of 0 and having an undefined slope are two different things. A horizontal line has a slope, its slope is 0. A vertical line doesn't even have a slope because it's undefined. All right, go try questions 1 through 5 on homework 2.3 because they're similar to everything you've just seen.